Hello everybody, today we're going to continue our analysis on Stirling cycle by filling out the table here. So before we start, let's refresh our memories on the 4 steps for a Stirling cycle. So state 1 to 2, this is a isothermal process, so delta T is the same, it's constant, so T1 is equal to T2. State 2 to 3 isochoric, so the volume doesn't change, so V2 is equal to V3. State 3 to 4 isothermal again, so T3 is equal to T4. And state 4 to 1 is isochoric again, so volume doesn't change, so V4 is equal to V1. Sweet. So now we can start looking at these problems and see what they want us to solve. So let's consider a Stirling cycle using an ideal gas. So hint, hint, we're going to use our ideal gas law later as a working fluid. Assuming that air is a working fluid and that R is 287 joule per kilogram K. And using the data provided in the chart below, fill out the empty boxes and list your assumptions and show all your work. So let's just list our assumptions first. Assumptions. Alright, we're already told that it's an ideal gas. So let's just assume it's ideal gas so we can use our PV equals to RT equation later. Additionally, we're also going to assume this is a quasi-equilibrium process. Forgive my handwriting. On top of that, we're also going to assume it's a constant. It has constant Cp and Cv. We don't necessarily need to use this for part A, but we will need to use this constant Cv and Cp for part B when we solve for internal energy and also enthalpy. So just remember this for now. And now we can start filling out this table. Before we even solve for anything, we can actually fill in a few values by looking at the process. So we said from state 1 to 2, it's an isothermal compression. So the temperature from from state 1 to 2 is constant. So T1 is equal to T2. So we can fill out this box here as 300 because T1 is equal to T2 is equal to 300 K. Another empty box is probably at this V2 here. So state 2 to 3 is isochoric. So V2 is equal to V3. So let's see, V2 is equal to this, is equal to V3 equals to 0.2 meter cubed per kg. And we also know from state 3 to 4 it's isotherm, so T3 is equal to T4 is equal to 500 K. Okay? From state relations, we know if we know 2 intensive properties, we can calculate the third. So here we can actually use our ideal gas law, solve for the third property. Since for state 2 and 3, we for these 2 cases, we all have 2 knowns and 1 unknown, so we can start either of them. So let's start with state 3 first. You can pick any one you want. I'm going to use state 3 here. State 3. Okay, so we're calculating for P3. So if we rearrange our ideal gas equation here, P3 is just RT3 divided by the volume, V3. And we know everything here. We know R is 287 287, and temperature T3 is 500 K, and the specific volume here is 0.2. Okay, that gives us P3 equals 2717500 Pascal. Okay, so we're going to put this value here, 717.500. Okay, so this is the first calculated value. Now we can move to state 4. So for state 4, we also have two knowns and one unknown. So we can also use this ideal gas law to solve for the unknown, which is the specific volume. So V is equal to RT. Here's V4, okay? So V4 is equal to RT4 divided by P4. And here we know everything again. So let's plug and chug. R is 287. T4 is 500 K. And the pressure is 205,000. And this gives us the volume at state 4 is 0.7 meter cubed per kg. Now we can put this V4 is equal to 0.7 in this box. And now we can move on to state 2. This is very similar to how we get P3. So state 2, P2 is equal to R T2 over V2. And we can just plug in all the numbers that we know. So 287 for R again. T2 is 300 K. And V2 is 0.2. So that gives us the P2 is equal to 430,500 Pascal. Okay? So we can put this value in the empty box. It's 430,500. Now we can move to state 1. But if you're wondering, hey, I have two unknowns. I don't know the pressure and I also don't know the volume. Wait a minute. You do know the volume because if you look at your state 4 to 1, it is isochoric heat rejection. So it's isochoric, so the volume at state 4 is equal to the volume at state 1. So we can write V1 is equal to V4 is equal to 0.7 meter cubed per kilogram. So in this case, we do know two properties, and we can solve for the pressure. So state, I'm going to use a different color here. State 1. Similar to what we did before, so P1 is just R T1 over V1, and that is 287 times 300 K divided by 0.7. That gives us 123,000 Pascal. Okay, so let's box. Oh, actually, not box this answer. Let's just put this in the empty box here. 123,000. So now we have all the values that we need. So mission complete! Yay! Yeah, and of course, I hope you found this video helpful, and let me know if you have any questions, comments, or feedback. Thank you.